Good afternoon, everybody. We'll go ahead and get started. My name is Jeff Clark. I am a UC voice architect for the Microsoft Consulting Services. We're going to spend some time this afternoon here to dig a little deeper into mobile devices. We'll start with some of the new features that we added to support mobile devices in 2013. Some of the new features that we've added for that as well. As well as some of the deeper call flows to really understand how this client functions, how this client signs in, and a little bit on how some of the media flows as well. So the agenda for this afternoon is really just what's new in Lync server mobility. We'll also look at how to plan, deploy, and manage your mobility service in Lync Server 2013. And then we'll take a high-level architecture view and, again, some of the call flow scenarios for some of the key sign-on scenarios and also for some of the calls as well. So we'll go ahead and start with the mobility overview section here. So with Lync Server 2013, we had some mobility goals that that we're definitely trying to reach, and we did reach. So one of the biggest things was cross-platform support. As we all know, we start running into issues when we start having to support a single application on multiple different platforms, on the iOS, on the Android, on the Windows platform. So we look from the server side, what can we do? So we introduced UC Web API, which is what we're going to talk a little bit about here today. There was also a deep dive session this morning on that as well, on just specifics of that API itself. So then we also looked at basically we need to have powerful real-time communications, as everyone saw with the Lync 2010 mobile platform and really any other of our Lync platforms we had for the mobile devices prior to that as well. It was really just a IM&P client, right? There was some audio capability, but there was definitely no direct audio capability in the client itself. So from there, we also really had to start look at we need to optimize this client for any mobile constraints, right? So we start having issues as far as battery consumption on these mobile devices. They can't be, in most cases, can't be running in the foreground all the time. They're going to just eat the battery. That's something that we really have to think about when we're putting these apps out there. We also have to think about bandwidth. Not everyone has unlimited 3G, 4G bandwidth available to them. We needed the option for to enable this to run over Wi-Fi or just to give the user that control. And then we really needed to simplify the deployment. What we saw in 2010, it was a little painful to set up mobility. And we really made great strides in 2013 just to make that process a lot simpler and a lot easier to deploy. So we start looking at some of the Lync clients that we have. So we've got our PC client, our Mac client, smartphone, tablet, browser. What's interesting about this slide is that three of those clients are all running off of the UC Web API. So the browser, the iPad tablet, and then a smartphone device is all running off the UC Web APIs. So again, when we start kind of talking about the mobile constraints, the disconnected apps was a big piece. Again, we really can't have that application running in the foreground, or if the user is going to background their app. If they happen to be on the application, that's fantastic, but we can't expect the user just going to, the only application they're ever going to have open is Lync. So we know the apps are going to get disconnected. We know they're going to background. So how do we bring those apps back to life? Again, from an IM perspective, if I initiate the IM, that's not a painful perspective, but if the app is backgrounded and I expect to receive a phone call, I need to find some way to bring that application back to life and attach so I can answer that phone call. Low battery budget. That's another one. We can't ship an application that puts a large strain on the battery of that mobile device as well. So we have the Windows Phone, which we can go ahead and background that application. The iOS phone, it has that ability as well. The Android itself is always the application is just always running in the foreground, even if it's not in focus itself. And then the third is the affordable data plan. Again, if you don't have the ability to have a always on or unlimited bandwidth available, or if bandwidth is just expensive from a 3G, 4G connection, if you may be roaming, you'll be forced to pay roaming charges. We give you the opportunity from the user to go ahead and require that the only audio and video to only work over Wi-Fi, or even for admins to set that as a policy for them as well. So here's a quick look at the mobility web updates. So we can see in Lync Server 2010, we had Communicator Mobile, and then we kind of jump forward here in Lync Server 2013 from October 12. We had the Lync web app itself that offer VoIP video, and what we did was when we introduced the UCW APIs, is really what opened up the door for the Lync web app, and then we leveraged that with the mobile devices as well. And then as we kind of look more in the future here, as you can see, we kind of continue to add the capabilities. In Lync Server 2010 for the mobility service, we added support for the contacts and groups and presence and IM. In Lync Server 2010, there was another mobile update that gave us the ability for PowerPoint viewing in iPad devices. And then we introduced here the Lync web app, where again we're running off the UC web API. And then in the February 2013 update itself, right, is where we really introduced, on the Lync Server 2013 side, is where we introduced the ability for the Lync mobile client for VoIP video. And then we're working on the application sharing as well. So you see here we talk about the application sharing for iPad only, and that's something that we're working towards right now for the other clients. So what we have here is just a view of some of the new features in 2013 mobility itself. So in 2010, and we're going to talk about this a little bit more, but in 2010 we had a 3-day registration. So now in 2013 we have a much longer lived registration. It's actually a registration that can live up for 15 days. That becomes important when we start thinking about, if I background an application, I go on a long weekend, and I don't happen to bring that application back to up to the foreground, and maybe I missed a phone call, or I took a long vacation, right? And just because I background the application, I really wasn't using it, I should still be able to receive that phone call. So again, in 2013, we added support for high availability. Another big piece here is the VoIP video in desktop and app sharing that we added in 2013 as well. VoIP sockets for iOS, that's a big piece. So what we really got away from, I should say, is the need for the push service for the iOS devices. We still use push service for the Windows Phone devices, but we can just have a constant VoIP socket with those iOS devices itself to receive events and updates for we can trigger the app to come back to life. The improved accept experience. So if I'm getting a inbound call or an inbound IM, we've extended that life for that toast to live. So now you have up to 25 seconds to actually accept that. A rich roster experience as well. So now if I'm in a conference call with the mobile devices, I can have a list of the roster. I can view all the attendees in that device as well. and we've added support for joining large meetings as well. In that scenario, we don't, with meetings over 250, we lose the roster list, but we are able to join those large meetings from those devices, though. So a continuation here, it's a integrated setup and simplified deployment for the web API, for really just installing the February updates. Now, instead of having to install a separate MSI like we did in 2010, now it's just all part of that cumulative update that we deploy. There's a lower TCO as well. So we don't require cookie persistence with the Lync 2013 clients. The front ends actually handle that persistence for us. So if you imagine a scenario back in 2010, if the client was a Wi-Fi user on the internal network, the load balancers would handle that persistence. So then if the user switched to 3G, either in the office or they just left the office, switched to 3G, we could then, the user could, when he signed back in, we could land him back on that same server again. Now, since with Lync 2013, now this particular user, no matter what front-end server he lands on, we'll bring him back to his home server. We'll bring him back to the server where he had that connection at. So new policies to manage VoIP and video on the mobile devices. So again, we kind of talked about the ability to turn on and off the requirement for Wi-Fi, for VoIP and video. So those are some of the capabilities that we have as well. Capacity planning tool. So now we can actually understand how to scale for mobility in a Lync 2013 environment. We're supporting HD photos from Exchange 2013 as well. And then along with that, right, we can leverage the Unified Contact Store with Exchange 2013. So under the mobility to deployment, there were some common goals here, right? So we had a common API and infrastructure for the mobile and web. An integrated setup with the Lync server deployment. And a big thing was really just trying to remove complexities, right? So when we start looking at, and we'll kind of dig into this, but in the scenarios where we have split domains, or if you're in a scenario where you have Office 365 and Lync on-prem and you're doing a split domain, how does that client sign in? How do we handle a user that might be on-prem or that might be in the cloud without that user really having to make any other changes? The user should just be able to put in their credentials and sign right in. They really shouldn't have to know if they're hosted online or hosted on-prem. So again, provide a common architecture for security. So the same security that we use for the Lync clients, if it's on the desktop or the mobile or the web, it's that same architecture across. So here's where we start kind of looking at just the mobility deployment itself. So when we start looking at the user, this is an external user, let's say. When the user is signing in, the user is going to go through a reverse proxy. It's kind of, so again, when we're looking at this web API, the client itself is you kind of think of it as an HTTPS client, right? It's not a SIP-based client in the sense that the Lync, desktop client is. So all of its communication, all of its SIP communication is going to ride through this reverse proxy. So it's going to land on this reverse proxy. It can land on here on pool 1. Pool 1 could potentially redirect that user to a different pool, to a different server, depending on where that user's homed at. We also kind of look here as the Lync 2013 client, if it was on the internal network on the Wi-Fi. We again have to hairpin that traffic back across the reverse proxy. So unlike the Lync 2010 client, the MX client that had a concept of internal and external, the web API doesn't. It's only an external connection. So when you look at the auto-discover process, if when we first sign in, when the client makes a request for Lync Discover internal or just Lync Discover, and we get back all of our URLs or all of our FQDNs, the 2013 client's only ever going to try and make a connection to the external web services or the external web API connection. So we have to enable that client to be able to connect. So we start looking at, since that interface and IIS on any of those front-end servers listens on 4443, we have to get that client to connect back to that. So from an internal connection, we show here that you can use a forward proxy to send to your reverse proxy. We've seen a lot of customers just shove that call or just shove that connection back across the reverse proxy. It could be just another interface on there. You can imagine it theoretically, it didn't even have to go across that DMZ reverse proxy itself. You could have more or less like an internal forward proxy that you're handling for Wi-Fi connections just to get that traffic back to the external web services. So we look at the client-server interop here. So what we have here is a Lync 2010 client running on a Windows 7.5 device. It's going to log into the Lync server 2010 MX services on the Lync 2010 server. That same device can log in on the Lync server 2013 as well. We run the web API and we run MX on Lync server 2013 as well. So you can, if you had a Windows 8 device, you can install the Lync 2010 client on that Windows 8 device, and that Windows 8 device could log into the Lync server 2010 as well. And then we have the Windows 8 phone, again, with that 2010 client, signing into the Lync server 2013. And then here's where we're actually running the 2013 client on that Windows 8 device, signing into a 2013 server. There are some steps here coming up where you'll actually get prompted or shown different experiences. So if I'm happen to be running a Windows 8 device and I'm running a 2010 client and I'm signing into a 2013 pool or 2013 server, I will actually sign in, but then I will get a notification that says, hey, there's a newer application for you that you can use. And then we can download that application and sign in. Here's just some of the details or some of the prompts that we actually have here. So in Lync server 2013, let's say mobility is enabled, and the Lync 2010 client signs in that we just talked about, they'll get a notification to upgrade, right? If we had Lync server 2013 but no February update installed, right? And we try to sign in with the 2013 mobile client, we would just get an error that you can't sign in, that you need to use the 2010 client. So some of the mobility policies that we have now for the IT admin or for the administrator is one here where we're going to enable the mobility itself. So once you deploy it, we can go ahead and turn that on globally. We also have the ability to control or enable VoIP as well. So if that's something that you don't want your clients to use for one reason or another. Another piece here to add is the ability to enable outside voice or enable the call via work or the single number reach, whatever you want to call it. So in the scenario where if a user does have, and we actually have a call flow on this later, but if a user does have VoIP enabled and they've got it set up where they require Wi-Fi for voice or video, or just to say voice in this scenario, and they're receiving a call, we can actually then place that call back over the PSTN, so it'll come back in. So they can still be reached via that device. It just won't be a Wi-Fi based call, right? Or the scenario if I'm joining a Lync conference and And again, I have the requirement where I require Wi-Fi, but I'm not in an area where I actually have Wi-Fi. We'll actually, instead of joining that call via Wi-Fi or via VoIP, right, we can actually have the conference call you back just like it does in the 2010 client as well. So here's some of those to limit data usages by employees here. So we can, we can set these for the employees to require Wi-Fi for IP audio. Maybe this is a setting that your company, purchases the phone, manages the phone, pays for the phone, just to reduce that cost. That's a requirement that you put on there or not. The ability to block push notifications if you need to. So obviously, if you have Windows phones, we're going to want to enable that push notification service. And then disabling of history on mobile devices. I hear this request a lot. Unfortunately, this is I guess you would say, a global policy, right? So it's not necessarily specific to mobile devices themselves, but you can actually disable this if you don't want, saving of history for all of your Lync clients. So we'll continue on with some limited data usages here. So again, we can require Wi-Fi for voice and video, require Wi-Fi for sharing, iPad only today. We also have the ability to manage notifications, right? So again, we can turn on push notifications on or off, and again, it's really only required for the Windows phone. Contacts, the phone book access on or off, or photos on and off, right? To be able to access your contacts on your mobile devices itself. Outside voice control. Again, that's the big key here. Even if someone didn't want this service, they basically would not enter in their phone number when they first sign into Lync, where we ask you what your cell phone is or what number you want to be reached at, right? That's what really enables us to be able to make that call. So here's we'll kind of go through a little capacity planning here. Let me just build this out. There we go. So, and we'll have another example here coming up, but we start wanting to look at, we want to estimate our mobility usage here. So we want to look at the user models that we have published. We want to look at the number of mobile users that we're going to have in the enterprise. How many devices per user? And then we're going to look at our current capacity. What's the number of Lync users that we have today? What's our number of front ends? What's our memory usage, or what's our CPU usage? So we have all of this today in our capacity calculator that you can use to kind of really help you start planning this. So once you run through this capacity calculator, it's going to tell you, with the additional users that we're adding for mobile, how many more CPU cores we need, or how much more CPU usage it's going to take, how much more memory potentially. We can kind of start talking about planning for failover, and then we start looking at and we want to kind of look at how do we monitor this system as well. So we want to look at available memory and CPU. And we do have some specific metrics we can actually look at for the mobility side as well. So here's just an example of a planning exercise that you could do. I mean, you can imagine you have an environment that has 8,000 Lync users. We have a front-end pool with 2 servers. As we all kind of know, or assume we know, Lync 2013 are recommended as 3. Right, but for this example, let's say we have 2 servers. Per front end, we'll split down the middle. We've got 4,000 users each, 6 gigs of RAM, and their CPU usage, is 60%. So our mobility requirement, we kind of lay into the mobility requirement. We're going to have 4,000 mobile users, right? It's going to be 1 device per user, just equal distribution. As we're looking at, and then so this calculator is going to help us spit out this data. So basically, we're looking at 4,000 mobile users. On the front end, we need 2.5 gigs of memory per front end. 18% additional CPU, and then we're going to spit out our recommendations itself. So if this is a calculator that exists today, if it's something you guys really haven't looked at, I would definitely recommend to download that and run through a scenario. So the mobility deployment steps for Lync 2013, right? So I mean, again, it's really a much simpler process than we had in Lync 2010. We're going to install the February update. We're going to update this on all front ends and directors, right? You're going to update. You're going to also update the back end as well. You know, assuming it's an enterprise deployment, you're going to update that as well. We're going to turn on the mobility policy, right, and set up any other policies that are required. You know, if you want to limit, you know, VoIP in any which way, or require or don't support outside voice as well. So we start, and then we'll go ahead and configure the push as well. So again, that's just for the Windows Phone 8 devices. And then for Lync 2010, it's still required for any iOS device as well, if you still have those in your environment. And then we can validate this deployment with our synthetic transactions. Lync Online, if you use Lync Online, or if you want to set up a trial, a test account for Lync Online, there's really no extra steps that you need to do to set up mobility. That's all handled on the Lync Online side. Monitoring, I promise we are going to get to some call flows. So monitoring, we have the performance counters. One of the, I guess, I mean, some of these counters have been there, right? But one of the things we really start looking at is really just the total requests in the web throttling and authentication. That's something new, the web API, right? So we really want to, if you're seeing any performance issues on the mobile devices, we really want to kind of dig in there and take a look to find out if we're having any issues there. As far as alerts or events here, so we can have the UC Web API, any initialization failures, any push notification failures. So again, from a Windows Phone perspective, if the app is backgrounded, right, and I'm sending someone a toast, or I'm calling them and they're not getting notified of that, right? I mean, that's going to be because of the push notification service, right? So we can look, and since this is all that push is happening from the edge via a federation connection, right? So we can look at the edge, we can look at the front end to see if we're having failures, with that service, right? Is that why the phone's not receiving those phone calls? If you bring that application to the foreground, right, then I call and then I receive it. Okay, well, I kind of just did some really basic troubleshooting, and I know I'm having some push notification issues, right? So we can kind of dig into it from there. Also throw events for any unhandled exceptions as well. So anything that we weren't expecting, we'll throw events for that as well. We also have synthetic transactions, right? So we can get information from the web API for conferencing for mobility. We can look at the connectivity to the Lync push notification service. So again, if you are seeing issues, we do have abilities to go ahead and test some of these synthetic transactions. From SCOM, we can bring in these synthetic transactions so we can be notified if we are having push issues. So you would know that, hey, all of my Windows Phone users potentially might not be receiving phone calls if there is some kind of push service problem. So here's where we get into the call flows. So we start looking at the UC Web API that's living on the front end, right? And it's talking to UCMA via HTTP, right? So all of our connections from our mobile clients, that's any connection they make is going to be over the UCWA connection. So it's auto-discover process. So the auto-discover process I'd say in one sense it's simple to understand, right? So we're going to make a request to Lync Discover, right? You know, it happens Lync Discover or Lync Discover internal. That's going to be handled by the web services on the front end server. If I was so something to kind of understand, if I'm internal, I can make a request to Lync Discover internal, but remember the UCWA response I get or that URL I get back is going to be my external web services. So as an internal user, I can make an auto-discover request to my internal web services, but when I want to actually connect to that UCWA API interface, I'm going to be connecting to the external web services. So that's where that's where we kind of hairpin back through that reverse proxy or have a forward proxy to get us back to the external web services. So any of the communication we have, any chat, say VoIP, more or less just say signaling perspective, right? Where we're actually communicating to that web API. That web API is talking to UCMA, which is that's what's talking to any of our other front-end applications that are talking to those other full-blown Lync clients. So what we'll have is again, you imagine we kind of talked about if the app is backgrounded, right? So what we do is we send events, right, to those clients to let them know that you're receiving a phone call or you're receiving a toast. Wake up, right? Let's bring that application to the foreground itself. And then the media flow. In this scenario, right, so this would be, thinking about it from an internal user perspective, that user maybe is on Wi-Fi, right? So we've connected to the web API via external web services, but the client's talking directly to the AV MCU on your front end in a conference scenario, right? So it uses the ICE protocol just like any other device does. So we are able to then negotiate the appropriate SDP. So I can, if I'm an internal Wi-Fi user, I can actually have a peer-to-peer audio call with another client or with another, API or some other MCU application. Like it'd be the AV MCU or like I said, if I'm calling, maybe I'm calling response group services or some, so we have the ability to talk directly with those other devices. If it's I don't have to, even though I'm an external user, my media doesn't have to be external of the network itself. So Lync Discover. So where is the web API? And then we look at it from an on-premises, hybrid, online-only scenario, right? So we kind of want to understand how does this user get signed in, right? And really, does it matter where the user is? So we look at, this is an environment where it says hybrid topology. Like we could be looking at, just consider it like a split domain, right? So we've got an on-prem deployment where we're set up split domain with Office 365. This particular user, Alice, maybe she's on-prem, maybe she's online. This scenario, she is online, but she shouldn't have to care where she is, right? So when Alice signs in, she's going to make a request to lyncdiscover.contoso.com. So lyncdiscover.her SIP domain. Right, she's going to land that request should go to your on-prem pool, right? So your on-prem pool knows that Alice is actually hosted online. So she can respond to Alice, say, Alice, you actually need to go to this other FQDN. Alice can then look up that FQDN, find out where that's located. That happens to be online. She'll then make that request or send that request to the online servers, and then she can then authenticate and sign in. And that's really just the auto discover process that's happening. Mobile presence. This is another big one here. So in 2013, we really added the ability to have more of a persistent or static registration or longer-lived presence that we don't kill this user after a period of time. So again, we look at Alice is signing in. She's signing into her home pool. This is a 2010 client, So she signs in, a endpoint is created, everything is fine. At some point, she backgrounds her application, she goes away from it, she launches something else. After 5 minutes of inactivity, we're gonna change her presence to away. After another 5 minutes of inactivity, right, we're gonna mark her presence inactive. After 3 days of no activity, so this was kind of the conversation we were talking about, where Alice goes on some, let's say, some week-long vacation. But, at the end of that week, she came back on Sunday, and her boss was trying to call her for some reason. She needed to talk to her, and she did not get that phone call, or she did not get that IM, as an example, in 2010. So now the endpoint, after 3 days, the endpoint's deleted. She is marked offline. Maybe Alice didn't know she was actually offline. So now with Alice still offline, Bob sends an invite to Alice, right? The user is unavailable. So now we look at what do we do different in 2013. 2013, we're looking at the same process. Alice signs in. So now it's UCWA that she signs into. So the endpoint's created, but we also create this static registration. The static registration here is the key point. So again, Alice navigates away from her app, and we're going to mark her presence inactive, we're going to mark her presence to away after 5 minutes. We're going to change that again after another 5 minutes of inactivity, right? So she's now gone away from the application for 10 minutes. And then here we'll actually clean up the user endpoint registration again. So now Alice has had no activity for 10 days. She's on an even longer vacation. So we actually can keep the static registration for up to 15 days. There's no way to define it. You can't make it longer, can't make it shorter. It is 15 days. But we do have the ability to, the thought is that the user is going to use this app again between the time they start and then within 15 days. If they're not, then they're not really using the application. So again, after 10 days of inactivity, she's still in the away state. Bob sends Alice in an invite. That static registration is there. We'll go ahead and recreate that endpoint from that static registration. Then we can go ahead and wake up that client, right? And we can bring that application back to the foreground. And then, like in this example, now she's in a call. It very well could have been a IM that Bob invited her to. So we look at VoIP on mobile devices. So we've got these PGET events, which is more for Android devices. VoIP socket is an iOS, and push notification is for the Windows. So we're going to run through a couple of these scenarios here. So again, we've got Alice. So this is a iOS scenario. So we've got Alice signed in, or Alice is on the internet, let's say. We've got a SIP Federation push notification set up. It doesn't really come into play in here, but to say it's there. So Alice will sign in, right? She'll sign into her pool 3 in this scenario, right? Bob is now making a call, right? So now we can that pool 3 can actually send that incoming call notification directly back via the reverse proxy, right? So back via UCWA, we can send that connection back to that iOS device to actually wake up that device so she can answer the call. And then we'll actually, she will get the toast or the notification on that device that someone's calling her. She can then answer the call. So she'll accept the call. And Bob says, okay, great, you accepted the call. And now media can flow, between Alice and Bob. So in this scenario, Alice is external, Bob is internal. So we're going to go through that same ICE negotiation that we do from a peer-to-peer call or from really any call scenario, right? So we can find the appropriate candidates. So even though the mobile device is a HTTPS device, a web API device, we'll still leverage the AV edge to allow that audio to happen in remote scenarios. Yeah, so the question was, once this is established, if the pool goes away, does the call could go away? Yeah, it's treated just like any other Lync client in that particular scenario, that the audio would stay up, right? You lose any mid-call functionality, right? But the fact is, my audio. I guess you would say, if I just lost my pool, then yes, I can still communicate, right? If I lost anything else, right, and it depends on the media, how the media got connected. Like, if I did an actual stun connection, because in this scenario, so I guess you would say, in a typical and take the cell phone out for a second, the mobile device out. In a typical scenario, if I have an external Lync client and an internal Lync client, my immediate path most of the times is external coming in would be coming in through the edge, for the media would come to the edge, and the internal going out would be going out via a stun connection via that remote users, like Lync's router, their home firewall, right? So we have different paths. So I guess in that scenario, it would depend, like, if we just lost the pool or if we happen to lose that data center. So there are scenarios where you could lose that call, right? But there's scenarios, obviously, of maybe multiple devices on the internet, right? It really wouldn't matter, right? So yeah, good question. Right. No, because it would, so if it would stay internal, and if you kind of look at it, and I don't know if you've looked at like how ICE negotiation itself looks, right? But when we send that invite out, we're going to send out my IP address, right, of how you can reach me. I'll send out like my IPs and ports. I'll send out my stunned firewall IP imports, and then my AV edge turned IP imports. So if we're both internal, even though my signaling is going into DMZ and back in, my SDP portion, right, my IP portion, which says, oh, I can talk to you directly, cool. Then we'll just do that audio stream connection that way. So push notifications, it's similar, right? It looks a little bit, so instead of having that VoIP socket, right, we kind of rely on that SIP federation connection we have. So again here, we'll make the assumption Alice is signed in, right? We've got kind of, Bob is making a call to Alice. The front end goes, okay, I need to send a call. I'm going to go ahead and send this push notification. It is a higher priority, so VoIP calls are higher priority push notification that the online push services will prioritize, right? So you kind of think of it almost like QoS tagging of some sort, right? So there's another element in there that says I get higher priority than just an IM, right? So a call comes in, we'll send it over to the 365 push services. That will go ahead and push that out to that particular device, so that device can be alerted that they have an incoming call. So again, here on the Windows phone, we'll pull from your local address book on your phone. So if you happen to have photos attached, right, we can show that photo as well. Right? We can show a name versus just like a phone number coming in. And then we'll say, yes, I want to accept that call, right? And then again, that media established is the same way. Again, it's if you're external or internal, right, we're still going through that same ICE negotiation process. So voice call preferences. So Wi-Fi, cellular, data, PSTN. So we really just wanted to give that user whatever options they feel they need, right? So if I'm in a Wi-Fi friendly area, then let's get my calls here. Like here, even though we can get Wi-Fi in here, it's not always the best, especially this week. right? So maybe there's a scenario where I don't want to get my VoIP calls via Wi-Fi. Maybe I want to force them to go via cellular, right? So maybe I can set that so if anyone calls me on Lync, it actually goes across my 3G connection, right, and not over Wi-Fi. So again, here we have we kind of have a scenario where Alice was signed in, she registered, she was on Wi-Fi, but then she signed off of Wi-Fi, or she turned it off for whatever reason, she dropped her connection, right? So now she's just on the 3G connection via Lync. So here we go. So it requires the Wi-Fi for VoIP settings. Bob makes the call again, right? So in this scenario, we go, we know, or you can imagine in this scenario that we've turned it off, right? That Wi-Fi is off, so the pool knows that Alice can't accept the call over Wi-Fi. So we're going to fall back to the PSTN in that scenario, right? So we're going to so the invite goes into the pool. The pool said, I don't have a data connection to Alice, right? Or the policy basically says that Wi-Fi is turned off, or she's turned that off. So we've updated the settings for Alice's registration. It says Alice is not using Wi-Fi, so don't try. So then we can hairpin that back, right? So that device, when she first signed in, she said my cell phone number is XYZ. So now we have that information about Alice. So now we can essentially send that call back out across the mediation server, back out to the PSTN, off to the outer gateway into Alice, and now she receives that call, even though she's not on Wi-Fi, but it's still a Lync call. You as Bob in this case, internal user, you called Alice. Call Alice, and she still received a phone call, but it happened to go over her PSTN or cellular network versus her Wi-Fi network. And again, in that scenario, I mean, the media flow is just what you would expect in a typical PSTN call. Yes, sir? You can do it as a user policy setting that you can turn those on and off. And then, Alice gets the call. So this, again, same experience. She doesn't necessarily have to know that she received a call on Wi-Fi or over the cellular network itself. And then here we're just showing the media flow itself, right? So it's just over the cellular network, out, to the PSTN, and then from the PSTN back into the gateway, and then Bob's talking to the mediation server as an example for his media path. So rich roster on mobile devices. So now we have the ability to view the participants and their modalities, or who's speaking, from our mobile device as well. So again here, so the client will receive this metadata roster list from the front end itself, right? And then we can now display this in this device. In the phone, we can actually see the roster list, or who's in the conference. So the mobile user is not disconnected from that conference experience. They have an idea of who's talking, who's in the conference themselves. And then here is just showing a little bit more detail about that roster list itself. So the Lync Server 2013 mobility updates. There's a little summary here. Is longer-lived registration as opposed to 3 days, and support for high availability. The support for high availability is really all. I don't say all, but it's a big part of the auto-discover process. So the Lync 2013 clients take advantage of this as well. So one of the good things, or one of the many things, I should say, in the scenario where you had multiple Lync pools, multiple edge servers, you always had questions of like geo load balance DNS for external users. If I lose an edge server, can I get them to sign in across a different edge server and then maybe back across my WAN to get to their other pool? Well, auto-discover really helps kind of answer that question, How do I do that? Well, we saw earlier, I can sign in. It doesn't really matter what reverse proxy I come into or what pool I land on. That pool will say, Alice or Bob or whoever, your edge server, right, or your UCWA connection that you need to connect to is X. So we can actually tell that Lync user what their edge server is based off the pool they're home to. So even if you had one Lync Discover record outside that pointed to a North America reverse proxy that landed on a North America pool, but it happened to be a EU user signing in, he would then know, okay, hey, my edge server is back in the EU. I'm going to now connect to my edge server directly. So from a Lync client perspective. So the auto-discover process is really big and really key. The web API infrastructure really allowing us to do a lot of what we're doing for the Lync client, for the mobile clients, for all those different cross-platform abilities. We can now manage. We have better control over the VoIP policies for voice and video. We have capacity planning tools. We added support for VoIP video, desktop, application sharing, and iPads. It's coming for the other devices. It's coming for the Windows device soon. Improve the accept experience. I mean, that's a big key there. Support the ability to join these larger meetings. And then having that same HD photo experience, if you happen to be using Exchange 2013 as well, and to use the unified contact store with Exchange. So we look at kind of just a backup here. So we've got this push notifications clearinghouse, right? Really, it's just kind of just understanding what the push notifications is all about, right? So it really allows us from the Windows 8 phone really to be able to background that application and still get toast notifications for IMs, toast notifications for VoIP calls that are again a higher priority. We can serve both on-prem, online customers via this clearinghouse that we have. Again, we used to use it. We still use it for the iOS devices for the 2010 clients, right? So again, that push notification would go to the Microsoft clearinghouse, and then we would go over to the iOS cloud to notify those other devices as well. So the scenarios that we're covering with this is the incoming VoIP calls, new IMs, MWI, missed call notification. Our provider is just Microsoft push notifications. That's the only clearinghouse that we have. And as far as administrating this, it's a federation that we're setting up with push.lync.com. We can enable this or disable this. It's pretty simple there. The ability to turn on push notifications, we can control that via policies as well. And then we can enable and disable the push notification service just from the client. If the client, for whatever reason, doesn't want to be notified, maybe they're not using the VoIP capabilities of that device, and they just don't want to be notified every time they receive an IM on that. I just want to, when I want to interact with that device, I will interact with the device. I don't want to be bothered when I'm not using the device. Troubleshooting. So I've been asked a couple times this week where we've had attendees come up to the booth that we're at and kind of show me their Windows phone and said, or whatever phone, and said, I can't sign in. Why? Fix it. It could be 365. It could be their on-prem solution, right? So you really look at the client logs, right? So, and that's kind of the first step. Really, the first piece is, is auto-discover working? Is auto-discover working? Is auto-discover returning back the correct FQDNs? Can I connect back to those web services? And then if I can, why else am I failing? Usually the client logs they're not the funnest logs to look through, but they're the most helpful logs, and they're really kind of your only choice, especially if you're a 365 customer, right? You really need to look at those client logs to really find out. We're hoping to publish some other troubleshooting guidance on mobile devices here, because there's a lot of, when you look at those logs, there's a lot of just, I don't want to say generic, but there's just errors in there that aren't clear what they mean, right? So hoping to kind of to make that a little bit clearer here in the future as well. Snooper can be used for analyzing the client logs. I use Notepad mainly if I'm looking for this. I mean, you can search for the word warning, search for the word error, you know, and you can filter out some logs that way to find out. I'd say more times than not, it's a TLS or certificate problem, either on your device or on maybe a reverse proxy or on a load balancer if you're going through that. That's where we've seen some issues. Seen some issues on F5 load balancers with not supporting TLS 1.2. So that's been another sign-in issue before. From the server side, if it's non-365, if it's on-prem, we can use CLS logger. I still tend to go the OCS logger path. It's a comfort level. I've been doing it for so long. If you're not familiar with CLS logger, it's the ability, set up with OCS logger where it was a one server instance. I would go to this server, I would turn it on, I'd turn on the component I want to log on, and I hit start. CLS, I can actually say I want to log this type of event, or I want to log this type of traffic, and turn it on for all servers in my environment at one time. And when I'm done troubleshooting or I'm done, you know, trying to test that scenario, I can stop them and I can collect it and I can dump all those logs into just one log if I want. So now I have one place that I can filter through all my servers, so I don't have to try and look at, you know, 10, 15 different sets of logs. And then what logs to collect is the API, the web infra, collab, and S4. Those are the components that we want to look for if we do have to do any tracing. So do we have any additional questions? I know we had a few as we're going through this. Is there anything else you want to dig into or talk about? Yes, sir.
Number normalization from the mobility client. Is it done on the client, or is it physically sending it to the ECWA, normalizing and coming back on it? The dial number and mobility, just whatever string it is, dials, and then I'll take it from your perspective and normalize.
Yeah, so we should be sending all that back to web services. Yeah, there's no local download. So like from the Windows perspective, right, we'll actually download all those normalization rules and hold them in memory. So yeah, we'll actually be sending that request to the front end as it is, and then the front end should be.
So have you seen instances where the phone mobility won't normalize?
No, I personally haven't seen that. But yeah, if you're ever seeing that, a good log is the translation services on the front end. That's where all of that normalization happens, is under that translation service. So that's a good place to look as well. Yes, sir. No, so the question is there any other requirements on the server side to support desktop sharing from the iPad devices? No, there's not that I can think of. No, I don't believe there's any additional policy to support that. It sounds like you're having an issue with it, or you just okay. Well, if you want to get with me after this, I can. I'll get you my contact information and we'll go through it. Okay, great. Yes, sir. Yeah. So what's coming in? I don't say the next release, but I say what's coming for the Windows devices, right? Or you know, is the ability to do application sharing, PowerPoint sharing, in that scenario. I believe that in that scenario it does leverage the WAC server or the Office web app server, but there's a internal thread on that. Like, are we just rendering? Are we only rendering via RDP scenarios? Like, so only you know desktop sharing, or are we doing that? I didn't get an official answer, but I believe we do. But I can, again, if you want to follow me, I can dig into that and get that question answered for you. Okay, well, if that's it, we are complete for the day.